More C-style array action, huh? I mean, I figure we can subscript it like normal, huh? We could even do, like we could do, sure. We'll create an enum gun, AK-47, foul, or we'll just say SA-58. It's a cooler name for it. M4A1, sure. And then we'll say, oh, okay. And then we'll do string view, needs standard string view. What if we do using standard string view literals? Sorry, using namespace, standard string view literals. Okay, and then we're gonna do a standard string view. We'll do a what if we tried const expression standard string view guns AK-47 string view, SA-58 string view, M4A1 string view. Oh, cool. Cool. But we could also have a const expression gun array called guns enums, guns strings, AK-47, SA-58, M4A1. And then we could have two different static. Oh, I missed it. Been too locked in here. Lock in. We need standard size, right? Isn't it include X utility? Need standard size and standard S size. These are not objects, these are functions. Okay, what are we going to assert? We're going to assert that the standard size of gun strings is max gun. Max gun. Hold. Hold. I don't think I think that's what it's a pointer. So I don't think we can pass C-style strings as objects. Well, what if we did? Well, it's not going to receive it by reference though, so I don't think it matters. What if we tried though? No? Alright, I'm interested to see how references will work. Oh, this is Virtual Insanity. Such a great song. What? Jesus. You're showing the best. Okay. Okay, and the point here is we're going to be, yeah, we can't static assert because we can't even get the size of them. Well, is it that we can't assert it? Because we did standard size gun strings. Didn't I? Or was it S size, huh? No? I swear I printed out the size earlier. Maybe it's the type. Int. Really? Still? List is not a type name? Standard size. What do you mean? So their size of what? Why does it care if it's a type? I'm not sure. I mean, because if we included array here. Oh, I think it's. Wait, hold. Oh, wait, well, we don't even have a fucking array yet. Oh, wait, no, I do right there. I have it right here. Wait, so it's okay here, but not out here. I guess we just can't. What? So I could run an assert, but okay. So I can't run a static assert on it though? What if we did static assert? Is it just because it's an array of fundamental types? So if we made this a standard string view, so I think I can only get the size of runtime ones, not here. Because I think maybe once they're const expression, they decay automatically to not be arrays anymore, so we can't get the size of them. What about, like, see, this is the array one. It doesn't take that. Okay, so no asserts here. But we could do... Can't use a range-based for loop. Can we do... while I is less than max gun? I mean, we can't even loop through... Well, because the point was we would use a range-based for loop with the enumerators, but now, if I have to use indices, then there's no point in me having an array of the enums. I may as well just index this now. Still? I think it is decaying automatically. What if we... Or is it just that it's const expression? No, I think it's that it's located there, huh? Because it's in global scope? No? Bro, are you sure? See, I made two of the same thing. We have... Can C-style only be of fundamental types? I mean, it can't be the case, because we've had objects earlier where we're using .data, so we don't have to cast, and those weren't fundamental data types in the arrays. I have a C-style array here of type integer. I have a C-style array here of type standard string view. I can reference this one by name, not this one though. Okay, yeah, I don't know what's going on. I mean, but sure, we could do the standard little, just print them, print an array or an integer one. Could we do const autoreference element x? Oh, range based works here. So it seems like fundamental types are the only ones that are good. Oh, not this one. This isn't any good. Let's remove this. Nice, so we can still loop through it like that. But we could also do... Fuck, I missed it. And everything works because it's a fundamental type. Okay. So maybe it depends on the data type. Well, what about... Don't string views deal with C-style? What if it was a string? Still works. Works. Wait. Huh? Wait, why is everything working right now? Was it because it was of the literal type? No. I'm just gonna remove that. Is there a major syntax error I'm making? I mean, what if we just made this a standard string? Oh, and then what if we just made this non-const? It's not that we're using the enums. Wait, was it the size? No, it wasn't. Oh, fuck. Bro. Bro. It was a fucking identifier error the entire time. Oh my god. Of course, gun strings doesn't exist. It's because it's guns strings. Oh my lordy lord. Don't even think I need it. Const expression gun enums what do we even say? Excuse me, guns E SA58 AK-47 M4A1. Now, what the fuck are you complaining about right now? What is happening here? Oh, well, because it's not an array. Ethan, use your brain, buddy. Guns E, guns SV. Oh, that's why. For the assert. That's why we needed the size. I'm gonna turn the light off so that the gnat goes to my screen. Should have been doing this whole time. Debate him. Static assert that standard size guns E is max gun. Dude, just go to the screen. Go to the screen. What the fuck are you touching me for? Or trying to? Nice. Okay, better. And now for const auto reference element, or we could just say gun, but I'll say element in guns E. So for each gun enum, I thought I got him. Bro, He just fucking goes crazy. This guy's going insane. Here he goes. He's falling victim to his racial debuff. He touched the screen once. He knows. He liked it. He's going for it again next. He has to. Okay, we're good. All right, arrays look nice. C-styles are solid. I was just being stupid. Boom. Gun storage. Ensure all gun values are stored. Okay. The index can be any, signed or unsigned. Yep, that's why we were doing .data to get a C style of the same values. Yep. Not subject to the sign conversion bullshit or sign indexing bullshit we had earlier. Yep. Cool. So we can have hey. Well, that guy should just be const expression. Honestly, that array. We have an array. We have an s, and then we output array with that integer as the index. Wowzer. And unsigned to do that too. C style will accept signed or unsigned. Doesn't do bounds checking. Let's see what happens if we do it out of bounds. Uh-oh. Uh-oh. Exception thrown deep in the memory. Here he goes. He's slowing down. He's going to touch the screen. Now, what if we remove X utility? Bro, he's just going so fast. Hold. What is it doing? Oh, cool. It is. I wasn't seeing that it was giving that error there. Cool. Or unscoped enums. No bounds checking undefined behavior if we access outside of bounds. Makes sense. Declaring an array. That's part of the declaration, not an invocation. Well, yeah. Yeah, I mean, that's obvious. Their aggregates make sense. That's how we've been making them. Yep. Directly initialize instead of having a constructor makes sense. Yep. Yep. I'm just going to open a white screen on the left to try and bait the gnat there. Yep. Copy list. Why would we do that? He's not biting. Default. Oh, great. Not initialized. Oh, if we don't specify. Are you sure? I mean, you said earlier the value initialized, bucko. I mean, you literally right here said that. But then we said they're going to be default initialized. Are you sure, bucko? Makes sense that we would just provide an empty initializer list. They're more than needed or more than accepted. Error. Fewer, it's okay. And their value because they are getting the, I guess, the implicit zeros in an initializer list. Nat's back. Almost must be explicitly stated. No class template argument deduction. Oh, well, makes sense because it's not a class template. Well, the audit doesn't work either. Ooh, rare. Come on, Nat. Oh, I'd like that screen. I'm gonna strobe him real quick. No? Okay. No auto. Omit a length. Length 5 elements. Oh, well, the redundancy here is that we're saying, hey, we've specified 5, and we've also done that. Yeah, we don't have to. We already showed in the beginning that we don't have to do that. Yeah, you showed that in the very, very beginning. At the very top of the screen, huh? Yeah, right here. He's gonna do standard size, huh? Yeah. Oh, omitted length. Gotcha. You're just not specifying. You're letting the initializers determine it. Okay. Gotcha. Well, yeah, makes sense. I mean, it needs initializers to know how many. It's not gonna deduce 0 from here. Oh, well, I guess it will deduce it to 0, so that's the issue. It's saying, hey, I'm not receiving anything, and that's the problem. Meaning, not that the array is dynamic, it's still a fixed length, but if you change how many initializers it's going to get, we don't have to go and change 4 to 5 or 5 to 6 or 5 to 4. Yep. One less thing to change. Omit. Okay. Let me test something. Okay, I figured. Still can't be constant expression. Makes sense. Oh, but what if we did, excuse me. Oops. Oh, well. Okay. Actually, wasn't that the thing? There is no literal for string, or is it? Or isn't it? I guess it is, huh? Bro, can we not? Oh! Fuck this guy. Gone. Oh my god. It's extremely fast. Hard to get with glasses on. Oh. Oh, I'm so happy. Oh. A pure room. Okay. They can be const or const expression. Depends on whether they're initialized as can be, but yeah. Makes sense. Wait, was there any purpose in even having program data here? Oh, the point is just showing that, hey, they can be const or const expression. That's it. What about, there's no constructor as far as I can tell, but what about copy initialization, huh? Uh-oh. Interesting, because it's saying that this isn't of type int. Or I guess it's saying from 3 to 1 is the issue. And then what if we said... okay. So you can't copy then. Can we make it temporary? Nope. Good. Bad. Seems like it can't be a temporary, I don't think. Well, dot data returns a C style apparently. That's also a temporary though. Or maybe that's because It creates one and returns a copy to it. So you can't explicitly get a temporary of it, but you can return it by value. Well, actually, how would you even return it though? Int, and then there's no identifier, so where do you even put the brackets? Okay, they can be constant expression. Cool. Well, there's no. Well, we could do size of. Hold. A number of bytes, but a size. Yeah. Well, yeah, and that's to get the size like that. But if we wanted to get the length, that's different. Makes sense. Size of. It's 20, because 20 times 5. Okay, so no overlap. Seems like no buffer. Note that there's no overhead, unlike standard vector and array, probably. Okay. Or at least standard vector. Alright, sorry. Like class types. Ignore what I said earlier. Like class types, no overhead. Elements and nothing more. Length, standard size. Are you sure size is declared in the iterator? I saw it was the next utility, bucko. I think that's what gets transitively included into standard vector. Well, but wouldn't iterator also? Or signed, yep. It's fucking scary. Makes sense. If we're not using array or vector, you'd have to go deeper. So if you included array or vector, you already have size like that. Also, you have the member variable too for dot size, but you don't have dot s size. So you need to get standard size, which is already included because iterator is included in array and vector. What about X utility? Oh. Oh, I wanted to do that again. That was great. Okay, iterator. Well, let's test. Hold. So it's fine here. We just can't call standard size here. Or maybe it's because no discard, huh? But it is because of no discard. You bitch. Wish you told me. Oh, because it thinks this is fucking defining something in namespace standard called size X that returns nothing? I don't know. That's weird. I've never seen something that doesn't return anything except a constructor. I mean, technically it returns a fucking object. It's not gonna do the crazy? Okay, it will. It's long. Oh, size T is also an IO stream, but sure, yeah. See standard different def for size T. The length, whatever. So size T is the number. Okay, so oh, that was good. What is this reference in parentheses? I've never seen this before. I could see a const T reference or a const T with some possible size. But it's not, it doesn't even have an identifier. Oh, well, I guess it doesn't have to, huh? But then you can't refer to it. Oh, but N has an identifier. So I guess you don't need it. You're just creating a temporary C-style string, copying, and returning the number that it was initialized with. Interesting. Takes a C-style string by reference. And that almost, it feels like it almost makes sense. Oh, never mind. Oh, because if we do a decayed array and we pass it, we're only passing one element and we don't know the size of it. So it would look like it's one element, but it isn't really. Okay. Okay. Type name T. Standard size T in. Void print C array size. And it takes, what does no accept? No idea. And it's a const. T, that reference syntax. N, return N. Oh, sorry. Wait, what? And so we'll say int x some size 1, 2, 3, and we'll print C, or we'll get And sure, we'll say length. Oh my god, there's another gnat. I can't. So now, what if I did that? Uh-oh, doesn't like it. An array of reference. What does that mean? Arrays of references. So it thinks. Oh, because it's seeing a const t reference. It's thinking that this is an array without a name, like, or with a name, but it's a t reference, and it's going to say the same shit here. No, sir, you can't have an array of reference. What we can do is say, hey, a reference to an array of t's. So it's an array of t's, of const t's, or a const array of t's, and a reference that we're passing by reference. But we don't have to do that. I think we could technically, no, maybe not. I guess we can't pass them by value like that. We have to pass them with the reference in the middle there. I'm eager to learn that syntax. Takes it by reference. See, like, that's how a template function that takes it by reference. I'm not passing by reference, it's taking it by reference. Seems like it can't take it by value. In this case, we have, oh, it's totally fucking up. Integer, or, well, an array of integers called array, or an object called array, an object named array. I'd rather say like an integer named this. In this case, it's an integer array called array with 8 elements. Oh wait, yeah, with 8 elements, all 0 initialized. We're printing the size of the entire thing, which should be 32, divided by the first index, which should be 4, the size of it. So 8 divided by 4 is, 32 divided by 4 is 8. Boom. Makes sense? Bro, what are you talking about algebra, bro? This is just regular shit. Oh, and it could work because pointer to array decays it to a pointer to the first element, apparently. And we'll apparently learn that later. Can fail easily when past an already decayed array. Gotcha. Meaning when we're using it in a function and we're passing a pointer to an array, because then it's a pointer to one element. So if we're getting the size of that, then it's the size of one. It's the size of a pointer to an int. Cover array decay next. They don't support assignment, so interesting. We can't say array 0 is 4. Wait, hold. Oh, meaning we can't assign the entire thing. We can't copy a whole thing. Well, I mean, we can't even do copying either. We tried. We can do to individual ones, but not for multiple. Meaning, can't reassign an entire array. Ah, okay. And if a C-style array itself is not a modifiable L value, but its elements are, then they can be changed while it cannot. Okay. Please copy. Yeah, I mean, I could just do it one by one and do a for loop. Say, hey, for this array, assign the same index of this array to be this value. Standard copy. What the fuck are we even seeing here? We have array and then src, and we're saying begin. So we're copying src into array. Begin src and src into begin array. Bro, what in the fuck? This is trash. Convert const expression standard array int 3a. 3. Well, yeah. So array of length 3, 0, 0, 0. Boom. And we can do the same thing by saying int x c style. And in this case, we could just say it's a length of 3. Boom. And if it's const expression, we can make this guy const expression too. Cool. 3 things that are wrong. Oh, we have more stuff. Cool. What are 3 things that are wrong with the following program? We have one, we have redundancy. We're saying create an integer array that is constant with length of 5 while giving it 5 elements to be initialized with, or while initializing it with 5 elements. You may as well just leave this blank. Output array length. What the fuck? If you do array length, that's the maximum, which you're going to get an off by 1 error because if you're trying to print the final element, so we're going to get, in this case, either an exception thrown or just a warning. What actually even happens if we... excuse me. Okay, so we do just get undefined behavior. Okay, so here we're going to get undefined behavior because length in this case is 5, and we only have 5 elements, which means the maximum element index is 4 because it's n minus 1, the size minus 1. So we get undefined behavior, we have redundancy, and I actually don't see a third thing yet. I mean, this seems... Oh, well, okay, that's really? It's a constant array, so we can't initialize it. Okay. True. I forgot. The index doesn't have to be a compile time constant, but the length does. So we can't actually initialize this with this size. We can index it here, but we can't initialize it because this is not a compile time constant. And we also get redundancy there too. So, okay. The length must be a compile time constant, which in this case it is not. It's a runtime constant, likely. And out of bounds, and it's also non-modifiable. So, GG. Square is a natural number whose square root is an integer. Hold. Meaning 16, 4, 25, 36, 49, okay, 81. We can make them by multiplying a natural number by itself. Make sense? 0, 1, 4, 9. Okay. A global constant expression C-style array to hold perfect squares between 0 and 9. Enter a single digit integer. You enter 4. The perfect squares between 0 and 9? Meaning 0, 1, 4, 9, that's it? Oh, really? It's kind of like ridiculous, right? Isn't that ridiculous? That's it? Bro, are you sure? This is kind of insane. Okay, and so we can get an integer from the user. So if we do 4, 5, and then negative 1 is by. Okay, so we can run it. Okay, so we could say while true, we're gonna get, we'll have a namespace perfect squares to 9. I will say perfect squares. Const expression int of some size called squares to 9. At 0, 1, 4, 9. Hold. The fuck? What the fuck are we? What are we complaining about right now? Hold on. Oh well. Oops. I fucking put that at the wrong time, wrong place. And so we'll say enter a single digit. All right. Okay, so we have a valid number now. This is input validation. And I almost want to put these like in their own input validation. Almost, dude. There was a slow nat and I fucked up. Prompt user, then there's input validation, sure. And then we're saying call this auto reference element in perfect squares to 9 if x is element, then we'll say what the number is a perfect square. Yep. Do we say x is a perfect square? Okay. Okay, we could say if x is -1, then what? We just say bye, and then return. And sure, we could return 0 as well. Early return if -1. Then we could say print square result. And then continue, right? And then we could say if they enter a number that's too big, enter number, oh, a single digit integer, here it is. Oh yeah, that's fine. So I don't even need to worry about handling that, it's fine. X is not a perfect square. Okay. Okay, so we say 1, hold, oh, oops. Wait. Oh, hold. The problem is it's continuing this one. So for each one, if it's a perfect square, I mean, we could also do bool is perfect. And then we could say here is perfect is true. And then we could say if is perfect else this guy. One is a perfect square, 2 is not, 3 is not, 4 is, 5 is not, 6 is not, 7 is not, 8 is not, 9 is. 10. Doesn't matter because we're already outside. -1 ends. And so what? We get the value. And then handle input, and then if it's -1, then we do these two things, early return, sure. And then we could check for each one of these. Eventually, if we get it, then we could output it's a perfect square. But if we continue, oh, we would need to break and return now. Or we could just set it to be true. Is there another way I could write this? If it is and we print it right away, we can't return, we need to get out. But if we continue, it won't work. And if we break, I think that's the best way of doing it, honestly. Or you could do the math with it as well. So you could say, is perfect square, return true. So we could also handle it like that, right? Well, is perfect square. And we take int, user int. Is that it? Yes, continue, hello? Well, I'm not gonna look that up, sure. Okay, so we could say so we could pass the user int, do this, return true or false, and then we could just say we could get a number, handle input, handle the early return, and we could put this in its own function, but we could handle the early return here. And then output. Well, actually, I mean, I guess we want to, actually, no, we want to continue. So we'll say x is a perfect square. And then we have this ternary guy in here. And we call is perfect square x. Hold. Oh, oops, duh, fucking wrong syntax. is perfect square. All right, what is... This is fucking scary. Is a perfect square or not a perfect square. Well, the problem is that's not even a space, so it actually should be fine. So we could say one, fuck. One is space. Oh, that's the problem. Is and then not. Or we could say is not space a perfect square or is a perfect square. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's see. Is 2 is not, 2 is not, 4 is 5. Yep, cool. Cool. Well, you may as well just do a ternary here. It turns it into one line. And I did this, but I took these 2 lines out. And then he didn't validate input. He just did that all in one line. And that makes more sense too, actually. Oh wait, well yeah, that makes a lot more sense. If it's -1, we may as well just break and then output by. Okay. C-style array DK, huh? The passing challenge, huh? An integer. Call print, we pass it by value. Okay. Yep. Copied into that parameter. It is printed. It's cheap and we're cool. If we have a 1,000 element C-style integer array, it's interesting that we can replace this with an and symbol in parentheses, reference symbol, reference operator. Okay. So we have a C-style array with 1,000 elements called integer x, and the first one is initialized with 5. The rest, remaining 99, are initialized with 0. We call print, and we pass it there. So what's happening? Is it copying 1,000 elements one by one into an array and then printing the first? Two major challenges, huh? Two issues. One, copying every single time. Oh, true. And if we have a fucking function that takes an array of 1,000, does that really mean that it only accepts one of a certain length, or does it mean that it can accept up to the length? What does that actually mean? Does it mean that does it even need a length? It seems like probably, but I'm not sure. Like I could see it working, but calls without arguments would be disallowed because then it wouldn't know how long the array should be. Okay, this music's pretty fucking good. How long is this fucking thing? It's not even looping. It's only 7 minutes? How in the fuck? What is this? What is this guy even wearing? Is that a black hole? This ability looks fucking super cool. Oh, I want to make more particle stuff that looks badass in Unreal. Okay, it's too cool. This is a great freaking fight. This is a great music right there. All right, so C doesn't have references. Oh my god! It only had pointers, which makes sense. References are just pointers, because I guess C++ is written in C probably. Is C++ written in C? Oh, it's not written in C, huh? Oh. Like, how is it even created? I have no idea. Oh, unexpected loop. pass my reference. Oh fuck, it's an extra version. Yeah, oh, not 1A, but it definitely goes to, listen to this. What? It's guaranteed to exist because a zero length isn't possible unless it's dynamically allocated from to the heap. Yeah, makes sense. Oh yeah, that's true, huh? Standard vector x. Is that how we even do it? I don't even remember. Need to type. Well, we would need to specify how long, huh? And if we did this, and we called print vector x. Interesting. So we actually did have to do... I forgot that that's what we've been doing this whole time. Tiny t, standard size t, size. And this entire time we've been doing t size. And then for const auto reference element in array element and print vector array. And really this should be called print array, but this is called x, not array, but whatever, it's called what it is. Okay. But then if we do standard vector, I think we only needed this for the standard vector part. Standard vector in reference hold oh, and this needs to be const hold, and this can't be const expression. I forget that we don't have to specify for vectors. Wowzer. So in here, how do we have a function that accepts different lengths if... Well, I mean, do we just do a template? And then hold... Fuck. Do we just do a template with a template type parameter? And then we put in an integer in there, and it's known at compile time, so it's okay if it's signed or unsigned? Different lengths, ideally of any length. C has no syntax to specify any length arrays. Oh my. Oh, because templates probably weren't even in C, huh? I'm gonna finish this a little bit here. If there aren't templates, oh. No syntax to specify any length arrays like a standard vector, which is determined at runtime, which is why it's not const expression. Can't be, excuse me. Nor can arrays of one length be converted to arrays of other lengths, huh? I mean, it makes sense, right? Because you have to reallocate. We'd have to take this 3-element guy, find a place that has 5 elements of room, copy these 3 elements there, and then value initialize the rest. Define an array with 7 elements. Initialize the first one to be 5, so 0 is 5. But 1 through 6 are not, or 0. Print element 0. We still have the array that's 1,000. It doesn't make a copy of it, because I guess it passes a pointer. But dereferences it automatically. And then we print the value. Somehow, the above example passes a 7-element array to a function expecting a 1,000-element one without making a copy. It's dangerous and not well suited for modern C++. Okie doker. Array to pointer conversions. Interesting. Okay. That's it for now.